on the same page. Okay, this is very critical. How do I know which one to use? The z-score or the t-score? Now, normally it's based on the number, but the t has one other little thing here. So for any of you that haven't read a flow chart, you come down, you get to here, and you answer this first one. Is n greater than or equal to 30? What is n? Sample size. N is my sample size. Is my sample size greater than or equal to 30? If it's yes, then you're going to use a z-score, a z-test, a z-interval, a z-test interval. You're going to use the z-interval. If you do not know the population standard deviation, you can use the sample standard deviation. Grab two of those sheets anyway to your desk. These sheets, okay? All right. If the answer is no, that it's not greater than or equal to this, then we test. Did they tell us that our population is normally distributed? If they said that it is, we can go on. If it is not, or they neglected to tell us, we have to stop. That means it's not going to approximate a normal distribution. So you can't go any further. If we get down here, yes, it was approximately a normal distribution. We want to know, do you know the population, you better write this on your notes, guys, population standard deviation. If you know the population standard deviation and your sample size is less than 30, you can then use your Z. You can use your Z-test on here. It is because you know enough about your population to be able to use your Z-score. Mostly our book, the problem with our book is it mostly will give us, if it's less than 30, it will always give us the sample one. So rarely we go to use that one. But in many books, in many articles that you'll read, I was telling you before, whenever you see t-scores referred to, you usually see sample sizes of like 600 and something. And they can still use a t-score because they don't know enough about their population. They didn't know what the population standard deviation was. So if that's not known, we come down here. A lot of books automatically bypass that one and come down here and do this one. So you're going to see like different, and I have seen differences in teaching in the books, the way they're set up. So a lot of books will do the, if it's greater than 30, they'll still end up using a t-score if they don't know this. So it depends on which one you're looking at. But our book will follow this one. So if you don't know your population standard deviation, then you can use this, and you can use your sample standard deviation. If this is known, you automatically use your z-score, even if you're a small sample. Sometimes you're going to see this used the opposite, like I said. They'll use it the opposite way. If it's a large sample and you don't know your population, they'll use a T. But our book uses it this way. So this is how we'll follow. And it's weird because I've seen like other kids that I've helped, theirs does it the opposite. So, you know, you just have to keep track of who's doing what. All right, so now, if you take a look, keep your flow charts handy. We're going to take a look at example 4. I can't expand this and show my flow chart at the same time, but your flow chart's right in front of you. Okay, you randomly select 25 newly constructed homes. This is my sample size. This is my N. Let's pull out all your information first. The sample mean is X bar, good. And the population standard deviation is this. This is my population. Assuming that these are normally distributed, should you use the normal distribution, the t-distribution, or neither? Now, you're going to have to follow your flow chart with this. So follow your flow chart. Is this n greater than or equal to 30? No. So we come down. Is the population normally distributed? They told us yes. So we keep going. Is the population standard deviation known? Yes. So therefore, we shoot to the right. And which one would we use, the Z or the T? The Z. You're going to use your Z distribution for this one. Okay, can everybody follow that flow chart? All right, you're going to check first to see what your N is. You're going to make sure that you're normally distributed. They have to tell you that. If they don't tell us that, we stop. That's a course in itself when things are not normally distributed. We check to see if we know the population standard deviation, we use the Z-score. If it's not known, then what will we use? T. Good. Okay. Let's try another one. That's, well, we didn't have to work it out. Then of course you would do this. You would do the whole thing using your T, your Z in that. They just want to know, can you follow the chart? But pull out your information. You randomly select 18 adult male athletes, and you measure their resting heart rate. The sample mean heart rate is 64 beats per minute, with a sample standard deviation of 2.5. Remember how we represent your sample one with an S. S for sample. Assuming that the heart rates are normally distributed, should you use the normal one is the Z, the T, or neither? So follow your flow chart. Is N greater than or equal to 30? No. So is this normally distributed?
Yes.
Yes. Do I know the population standard deviation? God bless you. No. So therefore, what do we use? T.
What would be a situation where you would use neither?
Neither? Okay, we're okay with this?
If the population
If it's not normally distributed. If you come down here, if you follow your flow chart, if you're 18, so you're less than 30, you come down, it says, is it normally distributed? No. And then you stop. See where it says, are you normally distributed? If this is not normally distributed, you stop.
This one it says you cannot use the normal distribution or the T distribution. Why can't you use the normal?
I'm sorry, say that again?
It is normally for the actual.
It is normally distributed, so you're coming down. Your N is greater than or equal to 30, right? You come down. Is it normally distributed? Yes. Do you know your population standard deviation? No. So then we're going to do it. Yeah. This time they didn't give it to us, but Anthony asked me when would it not be either. If they put this word in here, not normally distributed, or, guys, if they neglected to tell us. If they neglect to tell you, you can't use it either. They have to tell you.
Or just say either.
You just stop, say can't be done. Same thing with like when you do N times P is greater than or equal to 5. If it's not, we say can't use. That's a whole nother branch. Obviously there's other ways to test that, but that's a whole nother branch of statistics. This is just your elementary statistics, like what you normally find and how you normally process. Okay? Are we all on the same page? All right. So now, any questions? Flowchart's not bad. Flowchart's not bad. It does make sense. Okay. So let's go to one problem and do one problem together. Nice. Okay. Number 20. Everybody open your books to page 301.
What page? 301?
301, number 20. Little stone. Flamingo. You did? Good job. Okay. Page 301, number 20. Okay, the directions above this say a sample data set is given. For each data set, find the sample mean, the sample standard deviation, and construct a 99% confidence interval. Assume that the data is normally distributed. So we're automatically assuming that your data is normally distributed. Let's follow your flow chart. Mentally follow your flow chart. Is your n greater than or equal? Look at this guy.
So it's like number 20.
Number 20. I'm just doing number 20, but that was the directions for 20. Is your n greater than or equal to 30? No. Is it normally distributed? Yes. Do you know the population standard deviation? No. You can only find your sample standard deviation because this is your sample. So therefore, we're going to use a T. So how do I find my sample standard deviation and my sample mean?
Put it in L1.
Put it in L1. So everybody put this in your L1.
We were trying to say,
Finding your sample mean and your sample standard deviation.
it doesn't give me L1, it gives me L2.
I'm going to put it in L2. All right. So now, we found our sample mean, we found our sample standard deviation, and we decided we needed to find a t distribution. So, two things. We had to do a 99% confidence interval. So, we could do this guy. Our goal is to do this. Make your margin of error. Make your interval. This is our goal. This will give me my confidence interval. So, how did we look up the TC? How did we look this up? On your table. So if your n is 15, what's your degrees of freedom? 14. So you're going to look up 14. 2.977. 2.977?
No.
Okay. Times your sample standard deviation over your square root of how many? 15. So let's find our margin of error.
Wait, how did you get the
You go to your t distribution table, degrees of freedom 14, confidence interval 99, and you pull this off. It's right up on top. It's your first line, confidence interval. The problem said do a 99%. I didn't make it up. So what did we get? Round it to 2 decimal places. Round this to 2 decimal places.
Hold on, I got that. Divided by 0.79.
Good, thank you. Courtney's back in my good graces. Okay, so here's how we get our interval. So we take 2.35 and we subtract 0.79, 1.56. We take 2.35 and we add 0.79, 3.14. So, how do I interpret this? Darian, how do I interpret this interval?
Well, it's going to be, it's 1.56, and you have to guess.
So, what does this mean to me?
All that means is that the mean is right in between any of those two.
What mean?
The mean of the sample.
No, we already know our sample mean. I know what my sample mean is.
Yeah, the margin, yeah.
I know what my margin of error is. I don't need to do that to figure those out. My population. I am now 99% confident that my population mean will fall between those two numbers based on my sample, because I needed a way to infer some information about my population because I didn't have any information about my population. So I process my sample and I infer that information about my population. So now I'll be 99% confident that, excuse me, that my population mean will fall between those two numbers. That's why we do all this. I already know my sample mean. I already know my sample standard deviation. That I should not have to do all this for this, but I'm inferring about my population. Now, if I did a 95% interval, would it be narrower or wider than my 99? Narrower. I asked it backwards. If I did a 95, would it be wider or narrower than my 99? Narrower. The higher you go for your confidence intervals, the wider the confidence level, the wider the interval gets, right? Okay. All right, so now I'm going to give you some to do.